Communication Technology presents educational satellite television programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the formation of covalent bonds. Previously, we discussed the general properties of ionic compounds. We learned that ionic compounds are an ordered collection of positively and negatively charged ions. They are solids at room temperature due to the forces of attraction between their ions, and they require large amounts of energy to break these forces. We learned that ionic compounds are soluble in polar solvents, and that in aqueous solution, they are able to conduct electric current. In today's lesson, we will define covalent bonding. We will also describe the formation of a covalent bond. A lot of molecules are formed when the outermost shell electrons, also known as the valence electrons, are shared between two atoms. When electrons are shared between atoms, a covalent bond is created. This type of bond is usually formed when atoms of non-metallic elements combine to form molecules or compounds. For example, when two hydrogen atoms share their valence electrons, they form a hydrogen molecule, as you see here. When a hydrogen molecule is formed, each of the hydrogen atoms gains the stable electron configuration of helium, which is a noble gas. In a covalent bond, each electron within a shared pair is attracted to the nuclei of both atoms. Therefore, the electrons mainly stay between the two nuclei. The electrostatic attraction that is formed between the two positively charged nuclei and the two negatively charged electrons hold the atoms in molecular form. This attractive force between positively charged nuclei of atoms and the shared electrons in a molecule is known as a covalent bond. Let us look at a hydrogen atom and a chlorine atom as an example. These two atoms are attracted to one another because if they share an electron, then both will be able to attain a stable electron configuration. The configuration of the hydrogen atom will be like that of helium, and the configuration of the chlorine atom will be like that of argon. Thus, a molecule of hydrogen chloride is formed by a pair of electrons shared between the two atoms. Students, let us do an activity. What is the difference between the bond when two chlorine atoms combine to form a chlorine molecule and the bond that is formed when sodium combines with chlorine to form sodium chloride?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
It is nice to see you again, students. Were you able to explain the difference between the two different types of bonds? When two chlorine atoms combine to form a chlorine molecule, they are sharing electrons between them. This type of bond is called a covalent bond. When sodium combines with chlorine, sodium transfers an electron from its outermost shell to that of chlorine. By doing so, together they form sodium chloride. This type of bond is called an ionic bond. Thus, the difference between these two cases is that they involve different types of bonds. Is that how you answered? If so, you are doing great. Students, I am sure you remember drawing Lewis diagrams for ionic bonds. Note that the concept of Lewis formula representation can also be used to explain covalent bonds. The Lewis structure for covalent compounds displays the arrangement of atoms in a molecule and all the valence electrons for the atoms involved in the compound. The non-bonding or lone pair of electrons is conventionally represented by dots. Pairs of electrons that are shared between atoms are represented as dashes. Let us look at an example. For a hydrogen molecule, the electron dot formula looks like this. The covalent bond in a hydrogen molecule can also be written like this. You will be learning much more about the Lewis formula for covalent molecules in your next lesson. Students, let us try an activity. Now that you have learned about covalent bonds, please draw diagrams on a piece of paper to show the covalent bonds of the following molecules.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. How do your diagrams look? Perhaps you found it a little bit tricky to draw methane, but I am sure that you did not find this activity to be too difficult. Please compare your diagrams to the ones that you see on the screen. If you have made any errors, please correct them now. If you had any trouble, review your notes or ask your teacher for help at the end of this lesson. In today's lesson, we learned about covalent bonding. We learned that the attractive force between the positively charged nuclei of atoms and the shared electrons in a molecule is known as a covalent bond. We learned that atoms form covalent bonds with other atoms in order to attain stable electronic configurations similar to those of the noble gases. We also discussed the differences between covalent and ionic bonds. We learned that covalent bonds involve the sharing of valence electrons between atoms, whereas ionic bonds involve the transfer of valence electrons from one atom to another. In our next lesson, we will continue learning about the Lewis structure of covalent molecules. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.